Alright, in this video we're going to look at what we do when we divide rational expressions. It's not much different from multiplying. There's one additional step that we're going to have to take. But the idea here is that when we want to divide two rational expressions, we're going to convert the problem into a multiplication problem, just like we do with ordinary fractions. When we're dividing those, we convert it into a multiplication problem. And from there, it's basically exactly what we talked about in the multiplying rational expressions video. So if you look at this, here's an example of what we do with ordinary fractions. If we have the division problem 3/5 divided by 2/7, we turn that into 3/5 times 7/2. And this illustrates the process that we're going to use with rational expressions as well. A lot of people refer to this methodology as keep, change, flip, and I'm going to stick with that terminology here. We keep the first fraction the same. Notice 3/5 stays 3/5. We change the sign from division to multiplication, and we flip the second fraction. And that's the same thing we're going to do with rational expressions. Let's go ahead and look at a couple of examples of this. We're going to divide this. The first thing we do is we change this into a multiplication problem. So we change it into, we keep the first fraction the same. We change the sign to multiplication, and we flip the second fraction. And now we're going to handle this as a multiplication problem. We'll factor the numerator and denominator of both of these, and then go through our cancellation process. First numerator factors is x minus 5 times x plus 3. Second one, x plus 2 times x plus 4. Second numerator, that's x plus 1 times x plus 4. And the second denominator, x plus 3 times x minus 1. And now we look for common factors. We've got an x plus 3 and an x plus 3, an x plus 1. Oh no, oops. An x plus 4 and an x plus 4. I tried to cancel an x plus 1 with an x minus 1. That would have been a terrible mistake. And now we have what's left. We've got x minus 5 times x plus 1 in the numerator, and we've got x plus 2 times x minus 1 in the denominator. And there's our simplified fraction. All right, one more example of division, and we'll talk about a little bit about restrictions here. Another thing that's a little different with division and restrictions is we need any number that causes division by 0, either in the original problem or in the modified multiplication problem, needs to be excluded from the domain. So when we divide these two and identify the restrictions, any factor that appears in either of the original denominators is going to lead to a restriction, but also the factors from the numerator of the second fraction are going to lead to restrictions, because when we change this into a multiplication, they're going to be in the denominator. And so I change this over into my multiplication problem. And then I factor everything up. X plus 2 times x minus 2. 5x times x minus 2. X plus 4 times x plus 1. And x plus 2 times x plus 3. And now any of these factors are going to lead to restrictions. We've got those in the original. We've got these from the modified. So we're going to have all of these restrictions. X can't be equal to 0, 2, -4, -1, -2, or -3. And now we cancel. We cancel the x plus 2's, and then we cancel the x minus 2's, And now we're at the point where everything's canceled. And so we're into our final answer. We've got x plus 4 times x plus 1 over 5x times x plus 3. And there's our final answer. See you next time.